This video is on inheritance. And inheritance is basically when one class will inherit features from another class. And what that means is that if a class has certain member variables and member functions, then another class can inherit that class and then it will also have those member variables and those member functions. That is if the class allows those member variables and member functions to be inherited. And I will get into that a little bit later. But here's an example of class inheritance. So let's say we have a class that's called vehicle. All right, and inside our vehicle, we're going to define that a vehicle means that you have an engine, and then let's also say that a vehicle means that you have a certain number of wheels. All right, and so if we define this to be our vehicle class, and let me go ahead and put a function in here as well. So let's say that if you have an engine, then then you should be able to start your engine. So we'll go ahead and have a function called start engine. All right, so this is my vehicle class. Now, if I wanted to make a car class, then I don't need to start from scratch because since a car is a vehicle, then I can say that I can inherit the vehicle's features since a car is a vehicle, right? So the vehicle would be what's considered a parent. This would be the parent class. And if I'm going to make a car inherit the vehicle class, then this would be considered a derived class. All right, and the syntax to inherit a class is pretty simple. We just pretty much name our class, and in this case, I'm gonna call it car, and then I use a colon, and then I say public vehicle. And now my car has these particular member variables and member functions. It pretty much has anything inside public because I declared my car class to be a vehicle, right? So one thing, common mistake that people will make is that they will create a class named car and they will inherit it by vehicle, and so therefore they think that they would need to create public, right? And since a vehicle has a string engine, most people will try to create an engine and then an ant wheels. Uh, and the problem is C++ will allow you to do this, but what you end up doing when you do this is that you are now creating new variables for your car, and they will pretty much override the member variables that are inside of your engine, inside your vehicle. And so let's just look at this function called start engine. if this start engine makes some changes to its memory variable engine in order for it to be able to start the engine, then if I try to call start engine from my car, this start engine function from vehicle is going to make changes to this engine, but I put in a new engine. And so now start engine will not affect my new engine. It'll only affect the one that's inside a vehicle. And so my class will not work properly. And I know that's a little confusing. That's something to digest. So basically, where I'm getting at is you don't want to recreate the new variables the variables that you inherit from your class, because inheritance means that your class automatically has these, even though you don't see them in your declaration. They are declared here. They are declared here inside your vehicle class, and since you are declaring that your car is a vehicle, then you automatically get these particular variables. Now you could start adding new things, right? So since I'm a car, not all vehicles necessarily have doors, right? If a vehicle is a motorcycle, there actually is no doors. So since I said I'm a car, then I am going to add new features to my class. And this one, I'll call it doors, right? And so since I'm a car now, I can go ahead and create some doors. Let's think of some other things that a car might have. Maybe we would have a roof type. I'll just call it roof. Maybe we have a sunroof. Maybe we have a convertible. So those are some features that you can add to your car. And so if this was my car class, then I can go into into main, and I can create a new car object. Let's just call it C. And now, if I wanted to call the start engine function, I could do that. I could say C dot start engine, and this would work, even though I did not declare a start engine inside of my car class. My car class still has start engine because start engine was created in the vehicle. So that is basically a nutshell of how the right class works. And so this can be very useful so we don't have to reinvent the wheel. If we see a class that has most of the features that we want for our the class that we're trying to write, we can inherit that class, and then we can start adding on the features that the class we inherited lacks, so that our new class has all the features that we needed to have. So that is the basics of inheritance. So here's one thing to note. So notice that you inherit the public access the variables, right? The public member variables and public member functions. But what if my vehicle class has, let's say we have some private functions. Maybe I have a private function here, or let's say a private member variable named, let's call it like vehicle identification number. What if I wanted to keep that private? Now, if this is a private member variable, that means that only the vehicle class can access it, right? Because that's what we know what private means. It means that only the class can access it. And that rule still stands even for a class that inherits another class. Car will not have access to the VIN that was defined in public vehicle. So wanted, if I was writing vehicle and I want my derived class or my children to be able to access variables that someone from the outside could not access, then there's another access type that we can use. So instead of making this private, I can make this protected. Oops. And so the difference between private and protected is a very slight one. So if I have a protected member variable or member function in my class, that means that I cannot use it outside of my class. For instance, if I'm in main, I can't go and say something like this: C dot then equals 1, 2, 3, 4, or whatever. Right? I can't do this because it's protected. And protected is very similar to private when you're using it outside of the class. However, since it is protected, then my children can use it. So that means that car actually has access to the VIN. So I could do something like this if I was inside my car class. Let's just say that I'm defining something in my car class. Let me move my main down a little bit. All right, and let's say that I created a function inside my car class, and I want to call it getVin. Now I could do something like this, where I'm defining that function. I can say string car get VIN, and then I can actually say return VIN. Right, so I can access the protected inside my class, right? Since it's a protected variable, a child can access it in its class, but main still can't access it. Right, so let me repeat that. Vehicle has a protected variable named VIN, which means that VIN cannot be accessed outside of the class except if that class is a derived class, right? If that child inherits, if that class inherits vehicle, then the class that inherits vehicle is allowed to use that variable, but only inside of the class. I cannot use it outside of the class. All right, so that is protected. Let's talk about overloading. So right here we see that vehicle has a function called start engine. Now, let's say that I wanted to have two ways to start my engine, right? Let's say this is a car. And so let's say that vehicle, the way you start a vehicle engine is by using a key, right? And so now your car has the ability to start an engine using the key. But what if you wanted your car to be able to start by pressing a button? Well, the function is still starting engine, right? So it probably wouldn't make sense to rename the function, right? Maybe say start engine with button. We could do that, but we could also just keep the name start engine, but we just change the signature of that function, right? So I can say void start engine, and then I can just pass in maybe a Boolean. And basically, if I pass a Boolean to start engine, then it will start the engine by pressing a button. And if there's no Boolean, then it's going to call the parent start engine function, and it'll start the engine with the key. So this is called overloading. This would be overloading, meaning that now, if I go to my main, I have two ways to start. I can say c.start engine, and I can say c.start engine true. So now my car has two ways to start engine. It has two functions named start engine. Again, even though we only see one written in the car declaration, the other is written inside the parent's declaration. So this would be one start engine function. This would be another. Since car inherits vehicle, then it has both. All right, so let's say that the way a vehicle starts the engine, it's not quite the way a car would like to start an engine. Right? Let's say this vehicle, it starts it with a key, but then you also have to wait 5 minutes for the engine to warm up before you can do anything. And let's say that this car has newer features, right? It's a new cool model, so it doesn't really need to have to wait. So instead of using the vehicle's way to start the engine with the key, the car decides that it wants to redefine the way that engine is started. So now the car can go ahead and create a new function called start engine, and it's going to take on the same signature as the one in vehicle. So notice the one in vehicle here, we have void start engine with no parameters. So if car decides to create a function with that same signature, then now this is going to be considered a redefine. Which means that now car still has two start engine functions, but now it's not using the start engine function that vehicle defines. And it's going to define its own way to start an engine with the key. Right? So if we were to be inside of if we were to implement this, we would go void car start engine then inside here, we would write whatever we need to do to start engine. And so when I go into this function and I call start engine, before I wrote this new over redefinition, it was actually calling the parent start engine. But now that I did a redefine, it's going to call the cars. It's going to call the cars start engine function, the one that was defined in the car class. All right, so that is overloading. That's overloading and redefining a function when you're doing inheritance. All right, so now let's talk about some of the things that are not inherited. Right, so if your class has a copy constructor, then a child class will not inherit that copy constructor. So if you write a derived class, then and you need a copy constructor, you must implement that copy constructor inside your derived class, even if the parent class has a copy constructor. Also, the assignment operator. Again, that will not be inherited. So if your derived class needs an assignment operator, you must implement that as well. Um, what about destructors? Now, you would think that destructors would not inherit, and they actually don't inherit. Your derived class will not inherit the destructor from the parent. However, it will automatically call its parent's destructor. So you would still need to implement your destructor, but you don't have to implicitly call your parent's destructor. It will automatically get called. Oh, okay, I can't spell. Does not inherit. So destructors does not inherit, but it will invoke the parent destructor. All right, and so from the start of this class, I've always mentioned that there's four fundamentals of object-oriented programming. So I'm just going to say fundamentals. All right, and of course, the first one was encapsulation. All right, and we've covered that with classes, right, and having access and being able to write member functions and member variables. The secret word today is perfume. All right, and we also talked about what's the other one? It's inheritance. And that's basically what we just talked about, and that's basically derived classes. All right, the other two are polymorphism and abstraction. So I'm going to go ahead and give a brief discussion about polymorphism. All right, so polymorphism is basically kind of what I just discussed when we were talking about start engine, right? If the car needed to start the engine with the key a little bit differently than a vehicle, then it can override the start engine function and make that function work the way the car wants to work. And so polymorphism is very similar. The main difference is that polymorphism will not assume anything. Right, so let's say that I have a class named shape. Right, and inside my class named shape, um, let's say I have a function to draw the shape. Now, being a shape, I don't know how to draw every shape, right? So I'm not gonna make an assumption of how to draw a shape. So therefore, I'm not gonna even implement this draw at all. All I want to emphasize is that if you are a shape, then you have the ability to draw. And however you draw is on you, right? You define how to draw your shape. But in order for you to claim that you are a shape, then you must have a way to draw, right? And so the way we do this in C++ is we won't say void draw. What we will say is we'll call it a virtual function. We'll make it a virtual function, and then we're just going to set it equal to 0. And this is a really weird syntax. But basically is what it's saying is that I'm going to go ahead and create a function, and I am not going to implement this function, right? So you won't see something like this. You won't see something like this in the CPP file. Void shape draw, right? You won't see something like this. And that's why we have the equals 0. We're telling the compiler, don't look, right? When we go here, we're telling the compiler, don't look for an implementation of draw because it doesn't exist. We're going to make any class that claims their shape, we're going to make them implement that, right? So that means that if I was to go and create a shape, a new class that inherits shape, let's say circle, and I say it inherits shape, and let's say inside my shape I say public, and then I put in a function called a member variable called radius, right? With the shape, with the circle, we need a radius. Now, if this was my class for circle, and then I decided to go into main and create a new circle, then I'm going to get a little red squiggly line here because my compiler is going to say, hey, you claimed that you were a shape. And the shape says that if you are a shape, then you have a draw function. And look, buddy, you don't have a draw function over here. So you're not a shape, right? So then we will look and we'll say, oh, you know what? You're right. I'm sorry. Let's go ahead and implement that. So we'll go ahead and put in our shape. And now when you're making when your parent class is defining a virtual function, then you must use the virtual keyword. However, when you're now claiming to be a derived class of that parent class, you do not have to use virtual inside the definition, but it is always a good practice to do so anyways, just so that you and other developers know that this function is a virtual function, that this is a function that the derived class insists that you implement. Right, so I'll just go ahead and say virtual void draw. And now once I do that, that will satisfy this error. But of course, then I have to go inside my CPP file. And in my CPP file, I do not use the virtual keyword. I just use void circle draw. And then, of course, I draw my circle however a circle is to be drawn. And so now shape is happy. I am considered a shape now. Main is happy because I have the draw function, and circle is happy because now it has a way to be drawn. All right, and so that's pretty much polymorphism. And the reason why we do these virtual functions, right, is because we draw shapes differently. If I decided that I was a shape and I was a triangle, I don't draw a triangle the same way I draw a circle, right? And I don't draw a trapezoid the same way I draw a square, right? And so shape couldn't possibly know how to draw every single shape that's out there because, I mean, there's an infinite amount of shapes. So what shape says is that if you want to be a shape, then all you have to do is have a function called draw, and you implement how your shape is drawn. And so why is this important? Why is this important? This is important because let's say I have a program, right? Let's say I have a program in here that takes let's just make a function right now. I have a function and that function takes some kind of shape, right? Let's say it just takes a shape. And of course, this will need to be passed by reference if I'm doing it that way. But if I make my function take a shape, and then my function does something like shape.draw, if if my class didn't implement the draw function, then I won't be able to do this. My shape can implement the draw function because then it's going to draw every shape one way. That's why all of our virtual functions, excuse me, that's why we have to have a virtual function and insist that our children those implement those functions. All right. And so that's basically it for inheritance. Thank you for watching.